So in this problem, we have first we move from point A to B on a highway. Okay. Now we don't conserve the same velocity during motion, because they are saying that when we are going from A to B, so in the first stage, when going from A to B, half the time is driven at velocity equal to 110 kilometers per hour, and the other half of time driven at 130 kilometers per hour. So if I consider a time delta t, okay, so let's say to go from A to B, the total time is delta t. Okay, then for half of this time, so for delta t over 2, I'm driving at 110 kilometers per hour. And for the other half time, I'm driving at 130 kilometers per hour. Of course, the distances traveled in these two phases will be different, because I am faster in phase 2, so I will move a larger distance in phase 2. Okay. Now, the first question is to find what is my average speed. So what is the average speed? This is the first question. They didn't give me what is the distance between A and B, because it will be simplified, and we'll demonstrate this together. So the first question is to calculate the average speed when going from A to B. Okay, I should go back first to the definition of average speed. Do you remember what was the definition of the average speed?
Delta V L delta T.
It's the total distance. Okay.
Yeah, total distance.
Yeah, the average speed is d total, which is the distance separating A and B, over the total time of the motion, which is delta t. Okay, I will try to express this distance d function of delta t. Okay, I can say that this distance from A to B can be decomposed into two distances: the distance moved in phase 1 plus the distance moved in phase 2. How can I relate d1 and d2 to delta t? What should I do?
نعمل phases. phase 1 بنطلع distance will be load.
Yes,
phase 2
show it distance in phase 1.
110.
110 اللي هي الفيلوسيتي times delta t over 2. صح؟ تتذكروا انه اذا عندنا v constant, how we get d? d is constant velocity times delta t, v times t. Okay, so here, what is the time of phase 1? We said that the total time of traveling from A to B is divided into two halves. In delta t, or in the first half, delta t over 2, the speed is 110. In the second half, the speed is 130. So I can write that d1 is equal to v1 times delta t of phase 1, and v1 is 110. You can keep kilometer per hour, so the unit of velocity will be kilometer per hour, the unit of time will be hour, and the unit of distance will be kilometer. So it's 110 delta t1. What is delta t1? Delta t1 is delta t over 2. So I can express the one function of delta t. Now, the same for d2. d2 is the distance traveled during the second phase. So it's v2 times delta t2. Since v2 is given, it's 130 kilometers per hour. And the time in the second phase is equal to the time in the first phase, is equal to delta t over 2. So I can get the distance traveled in the second phase. And now the total distance between A and B will be the summation of D1 and D2. So if you sum these two, you have delta T over 2 can be taken into factor. So you will get the following. You will get that the total distance traveled by taking delta T over 2 into factor is equal to delta T over 2 times 110 plus 130. So this will give me 240 over 2, 120. So the total distance is 120 delta t. And now, if I replace into the expression of the average velocity, I have that V average is d total over delta t. So it's equal to delta t will be simplified. So as you can see, you don't need to know what is delta t, because it will cancel out and the remaining will be 120. So the average velocity is 120 kilometers per hour, which is actually the average value of 110 and 130. You know why you can expect this result? Because the time at which I traveled at 110 kilometers per hour is equal to the time at which I traveled 130 kilometers per hour. So they have same weight of time. This is why the value I obtain is exactly the average of these two values. What is more challenging is the second question. In the second question, they said that when I go back from B to A, and now when I change sense and move now from B towards A, instead of having half of the time velocity 110 and the other half 130, now it's a little bit different. They said that on the way back, you travel half the distance at 110 and the other half distance at 130. So now, if you will calculate the average velocity, it will not be 120 because I have different times for the first half of distance and the second half of distance. So how can I find now the average speed when I go from B to A? Okay, so we'll do similar analysis as we did before. We said before, here we have a certain distance between A and B. Now, for the first half of this distance, for a distance of d over 2, we are traveling at 110 kilometer per hour. And for the other half, d over 2, we are traveling at a different velocity of 130. And then we go back to the definition of average speed. So to get the average speed from B to A, speed average from B to A is equal to the total distance traveled, which is d, okay, over delta t total, over delta t of motion. Now, the total time delta t can be decomposed into two parts. The time of phase 1, so I can name this time here delta t1, and the name here for the second phase, I consider that I have to move this distance at another time delta t2. Of course, it will not be the same time, because in the second phase, I am faster than the first one. So I will try to find an expression for delta t1 and delta t2, and then say that I will replace delta t in the equation by delta t1 plus delta t2. So this is d over delta t1 plus delta t2. And now I will try to express delta t1 and delta t2 function of d, so that d will be simplified from my equation. Okay? Let us see how to do it. So first, what I know about delta t1 is that I'm traveling during this time a distance of d over 2 at a velocity of 110 kilometers per hour. So you know that for constant velocity, the time is distance over v. So I can say that delta t1 can be replaced by what? Delta t1 is the distance traveled in phase 1, which is d over 2, over the average velocity for this phase. They said that for the first half of distance, the velocity is 110, so it's over 110. While for delta t2, I'm traveling same distance, but now at another velocity. So delta t2 is d over 2 over 130. Now, let us replace back into the equation of speed. So the average speed is then equal to the total distance d. Now I will replace delta t1 and delta t2 by their expression. So it's d over delta t1 plus delta t2. When you add these two, d over 2 can be taken into factor. So it's d over 2 times 1 over 110 plus 1 over 130. Okay, and as you can see, d will simplify. So you will obtain that your average speed can be calculated as 2 over 1 over 110 plus 1 over 130. And you can use your calculator to determine what will be the value of this average speed. Okay. Any question on this?
بس to recheck دي
Yeah,
على طول انه half the distance هي ما هيك؟
exactly. Because you decompose motion into two phases, and in each phase you are traveling half the distance.
Okay, thank you.
Any other question on this? Okay. Now, they are asking me to find the average speed for the entire trip. What will be the formula that you will use if I want to consider the whole trip of motion? So the whole trip
We just add them
is going from A to B, then
from B to A.
then moving back from B to A. Can
يعني
I
احنا جبنا
do
from
can I do the average of both, do you think?
احنا
ما هي زي
عملنا
الديستنس فينا
نحن
عملنا
جبنا
التو سبيد
جبنا الافريج سبيد بالروحة، وجبنا الافريج سبيد بالرجعة. إذا بدي آخد كل الباس اوف موشن جيب الافريج سبيد تبعه. What should I do؟
ما فينا نعمل تو سبيدز بلس بعض على 2.
لا، تعرفوا ليه؟ لأنه التايم منه هو ذاته. يعني لو time of going from A to B is the same as the time of going from B to A، فينا ناخد الافريج over 2، نعمل summation over 2. بس because you are traveling the same distance but at different times, then to calculate the whole average speed you will need to go back to your equation وتقولوا انه اذا بدي اخذ كل الباس of motion شو حتكون التوتال distance traveled؟
2D
2D. okay, and what is the total time؟ نحن بأول phase مش جبنا t d function of delta t، يعني نحن معنا relation انه delta t of phase 1 function of the distance. if you remember in the first phase, okay, we said انه average speed شو طلع معنا؟ طلع معنا average of 110 و 130 صح؟ اللي هو 120. So when we go through the first phase from A to B, okay, we have that delta t of this path is the distance traveled, which is d, over the average speed during this path اللي هي over 120. And in the second phase we studied, we just have developed together now what is delta t. So this is delta t of phase 1, which is going from A to B. Okay, now function of the distance d. Now delta t of phase 2 when going from B to A, we just have found its expression. Okay, we said that it's equal to شو طلعناها هلا؟ دلتا تي. خلينا نرجع نكتب الاكسبريشن تبعها. قلنا انه for delta for d equal to مشينا half the distance okay at a speed of 110. يعني for the first part of going back from B to A, the time needed was d over 2 times 110. okay, while for the other half of the motion the time was d over 2 times 130. okay, so now as you can see we can find the total time of motion. The total time of motion is delta t1 plus delta t2. okay, so the total time of motion is d over 120 plus d over 2 times 110 plus d over 2 times 130, and the average speed for the whole path. So now we can say that the average speed for the whole path total is the total distance traveled, which is 2d, over the total time of the travel, which is d over 120 plus d over 2 times 110 plus d over 2 times 130. And if you simplify d from your equation, you will get the total average speed. هيبين معكم انه هو different than 130 120 sorry. ما بيطلع average because it's not the same time. Okay, so simplifying d and doing your calculation, you can get what is the speed for the total path of motion. Okay, now who can tell me what is the average velocity for the entire trip? This is the easiest question. Average velocity, not speed, for the entire trip. I went from
أعطيت زيرو.
it is 0 because I went from A to B, then I went from B to A. So what is my displacement during the entire trip? Since I got back to the same position, delta x for the entire trip is 0. So the average velocity is 0. So this is 0. And this is why we said the average velocity will not always give me a good representation of motion, because it's just take into consideration the initial and final positions without taking into consideration the total path of motion. So if I change sense, the average velocity cannot track this. The average speed will be more significant when I have change in sense during motion. Now, they are telling me to sketch x versus time. Okay, assuming the motion is all in the positive x direction, and indicate how the average velocity can be found on the sketch. Okay, so if I want to sketch x versus time here, I will have to select a scale, okay, because I don't know the total distance, but I can scale it as d with respect to d. So I know that the total distance is 2d traveled. Okay, so now if I want to sketch x versus time, so this is x and this is t. Okay, I know that the maximum value of x is what? Is I started from 0. Okay, and I considered that A is at the origin, and I moved first from A to B, then from B to A. So what is my maximum x if the distance between A and B? D. Because the distance between A and B is D, then first my maximum x is D. I know this. Okay, now they told me that for half of the distance, okay, I moved at a slope of 130 kilometers per hour. So if I want to do a graphical presentation, I will take my rule. I will take d over 2 here, and I will draw a line of slope 130 kilometer per hour. Okay, so if I draw this slope, so I can annotate the slope like this in the figure. This is 130 and corresponding to 1 hour. So my scale will be x in kilometer and time in hour. Okay. Now, what will happen is that the intersection between this straight line and d/2, okay, will represent the time needed for the first phase. So graphically, I can find this time, okay, by saying that since I know the slope of this line, then I can say that this delta t is in a way that, so this is delta t, if you want, of the first, when I go from A to half of the distance. And if I divide my path into phase 1, 2, just 1 second, guys. For the first, when I went from A to B, they said that the time was the same. Okay, so excuse me here, because هيديكي backward motion. Let me fix it. Okay, so when you went from A to B, if you want to graphically represent this, they said that half of the time I was moving at 130, and the other half of time I was moving at 110. So because the time was divided into 2, so this is delta t over 2 and delta t over 2. How can I graphically find, if you want, what will be the corresponding distance traveled for each case? I can say this. Because I have the same time of motion for both phases, okay? And for the first phase, I have a velocity of 130, and for the other one, a velocity of 110. So I can say that for the whole path, when I go from A to B, the average is 120, okay? The average velocity is 120 because it's the same time. So they have these two velocities have the same weight for time. So if I want to graphically find, if you want, the value of distance traveled in phase 1 and distance traveled in phase 2, all I have to do is the following. So first, I do a graph. I say that I know that the maximum distance that I will reach is d, and I will reach this d for a total time delta t, and I know the value of the total time. Why? Because as I said, you have these two phases are of same weight factor. They are done for the same amount of time. So in total, I will travel a distance d with an average velocity of 120, which is just the middle of 110 and 130, the average value. So the total time of phase 1, I know that it's equal to d over 120. Okay, and since I know this, I can determine what is half of this time. So half of the time will be equal, so delta t of, if you want, phase 1 and phase 2 is d over 240. So I can write here just, this is delta t over 2. I can put it on the graph, and then to find what is D1, what is D2 graphically, I can just draw first a straight line of slope 130. It will intersect delta t over 2 at a certain point. This will correspond to D1. So this will correspond to D1, okay? So you can say that D1 can be calculated as, you can calculate it graphically with your rule, you can measure it, and you will get exactly the result that you got from calculation, that D1 is equal to the slope, which is 130, okay, times delta t over 2. And delta t over 2 is d over 120. So this is the first phase when you are going forward, okay? Now, to get the remaining distance will be d minus d1. So in the second phase, you will move this distance, and you can just here do a straight line with a smaller slope, because now you are moving at 110 kilometer per hour. So if I want to represent graphically as the second stage, it's a smaller slope. It's 110, and it will stop at delta t. Yes? Who was asking a question?
لا مش I wasn't asking, I was answering. تاني وحدة لازم تكون طالعة يعني. Yeah, okay, تمام.
Okay. So this is 110, and this is a 1. Okay, and you can verify that the average slope, if I go directly from this point to this one, the average slope will be 120. Okay, so mathematically this will be clear that if I take this slope, it will be 120 over 1. Okay, now this is for the when I go from A to B. Now in the backward situation, when I move from B to A, I want to represent also how my graph is varying. When I'm going back now, for half of the distance, I'm moving at a velocity of 110 first, and then 130. So how can I do this? Already on my graph, I have the total distance. So I look at my graph, I take the point corresponding to d over 2, and I say that for phase 3, let us call it 3 and 4. So as I'm moving back, when going from B to d over 2, it's phase 3. So let's say d over 2 is somewhere. So it's the middle between A and B. Okay. So when I go from B to half of the distance, this is phase 3, and then from this point to A, it's phase 4. So to represent phase 3, I say I should reach here. I should reach d over 2. So I take my rule. I take half of this distance, and I say if I take a horizontal line, it should intersect with a line of slope what? The slope now will be negative or positive in phase 3 of velocity. Distance with respect to time will be decreasing, or x with respect to time will be decreasing or increasing when I move backward from B to A. When you move back, okay, I am considering that A is the origin, and the positive direction is from A towards B. When you move back from B to A, your velocity is negative because you are moving in the negative direction. So your slope will be negative, but x will remain positive. Okay, x is positive because you are still at the right of your origin, which is A. So now when you move backward, the velocity will be negative. So the slope will be negative. Since they told you that you are moving at a slope of 110, this means now that the slope is minus 110. So it will be, if you want, symmetrical with respect to this part, but with a different distance, okay? Because now you are moving half of the distance at this slope. So you will stop at the intersection between the line of slope 110 and d over 2, okay? So here you can represent the slope like this. This is 110. This is 1. And it's a decreasing slope. Now, when I reach this point, my slope will become more negative because now I will move at 130 kilometers per hour. So I will increase the negative slope and will continue to move down until reaching x0 because I will be back to point A. Okay, so here I can represent this by a slope, a negative slope of 130. And this is 1. And if you want to find graphically the average slope during the second phase, you just join these 2 points. The point from this is B, this corresponds to B, and this corresponds to A. If you measure this slope, you will get a negative value, and this negative value will be equal to the average of the average speed when going from B to A. Okay. Any question on this, how we did the graph or anything? This is a very important problem, okay? Because it is a review on average velocity, speed, how graphical interpretation and representation of motion, etc. Okay? Do you have any question on it? Please ask if anything is not clear.
مدام ضروري السكتش نجيب القياسات على القد.
هلا اذا كانوا طالبين منك تطلع values من الجراف اكيد. يعني هلا انت كيف بتعملها؟ بما انه انت ما معك الفاليو اوف دي، بدك تاخذ سكيل، اوكي؟ يعني بقول انه دي correspond to على to 10 squares على الجراف تبعي. يعني مثلا باخذ دي 10 squares.
اوكي.
So this is my scale and I work on it. فبس تاخذ scale معين you will be able to measure your slopes. Okay? So you can deduce average slopes from the graphical interpretation. Any other question on this? So please try to do these problems. Try to repeat these problems and continue the remaining ones because it will be a review for you. Now, one problem per day you will finish. Okay, so it will not take a lot of your time and it will prepare you for the exam. Yeah, let's see you next time. Okay.
Goodbye. Thank you.
Bye bye.
باي.
Bye.